Hello, today we'll be learning how to do algebraic factorization. So it sure looks like it is a very difficult term, but it is actually very easy, believe me. So this chapter can be summarized into three main learning outcomes. Firstly, learning how to factorize an expanded expression. So what does this mean? So it can be as simple as AB. This is an expanded expression. So how do we factorize this? Okay, factorize this by taking out a common factor. It becomes this. Okay, so it's not as hard as it looks. Okay, the second outcome that we have is learning these special algebraic identities. So I won't list all of them down here, but there are three of them. So they will be your best friends if you want to ace this topic. And the third learning outcome that we have is to learn to apply a mix of algebraic identities in a question. So this would be the mix of outcome number two. What do I mean by all of this? Let's find out in the subsequent slides. Okay, so let me introduce you to my very good friend, Mr. Factorization. Okay, factorization is the opposite of expansion, and expansion is the name of my very good friend. Okay, she's called Miss Expansion. Okay, so factorization means to reduce an expression to its building blocks, which are the terms in the bracket. So what do I mean? So for example, over here, okay, this guy known as the expanded form. Okay, and I want to change this guy to the factorized form. This guy is the factorized form. Okay, so how do we do this? Okay, so specific to this example, this will be using a grid method. Okay, so let me demonstrate. So x squared. So to get x squared, okay, how do we get x squared? It's basically x times x, right? So we get x squared. Okay, then we look at this term, negative 8, right? So how do we get negative 8? It's negative 2 and 4. Okay, so you get negative 2 and 4, you get negative 8. So this x times negative 2, we get negative 2x. X times 4, we get 4x. And we add them up together, we get 2x, which is the guy in the middle. Okay, sounds like I'm talking something that you don't understand. It's okay, this is just to show you an example of what is expanded form, factorized form. Okay, this is the factorized form. Okay, the other example that's easier to understand is this is the expanded form and this is the factorized form. So what you notice is that the factorized form is always the guy in the bracket, right? Okay, the expanded form, no bracket. Okay, so this is the main idea that you take away from this slide. To give you an idea of how to approach questions in algebraic factorization, there are four main steps before you factorize an expression. So the first one would be to take out the common factor. Okay. Step two would be to identify special algebraic identities, which are your three best friends. Okay. First one would be a squared plus 2ab plus b squared will be equals to a plus b whole thing squared. And step two, part two will be the a squared minus 2ab plus b squared will give you your a minus b whole thing squared. And part 3 will be a squared minus b squared equals to a plus b, a minus b. Okay, the third step would be to use the grid and cross method. Okay, and the fourth will be grouping method. So it is in sequence. If let's say you see an expression, you cannot use step 1, you try step 2. If you cannot use step 2, you try step 3. Then lastly, you try step 4. Okay. So the step 1 will be to start out with the most simple thing, which is to take out the common factor. So this was actually covered in secondary 1 syllabus. Okay, to factorize an expression with a common term such as this 2x plus 8c plus 10e, okay, the common factor among the three terms is 2, right? So if you divide all three terms by 2, you stuff them in the bracket and you bring them to outside. You bring the 2 to outside the bracket. So this is what you get. See, this was the 2 that you divided by, and this is what is left behind. Because you see, this divided by 2, you get x. Okay, this divided by 2, you get 4c, and this divided by 2, you get 5e. Okay. Okay, let's have some further examples. So the common factor among these three terms is -7, right? So you see this guy has a -7 here, there's a -7, and there is a -7 here also, because 70 divided by -7, you get -10. Right? So to put this into practice, okay, you divide all the three terms by -7, put the -7 outside the bracket. Okay, and what we end up with is the terms that are left behind, which is B, 7F, and -10R respectively. Okay, so similarly, if you see -49F, if you divide by -7, you end up with 7F, and that is where you put this guy inside. Okay, so we have come to the highlight of this chapter, which is to learn to identify special algebraic identities. So if let's say we take out the common factor, we've already taken out the common factor in step 1, or if there are no common factors, we will proceed to step 2, okay, which is to identify these algebraic identities. Okay, so these algebraic identities are very, very important. Okay, they will be the one that remembering these identities, it will save you a lot of time. Okay, so it's actually not that hard to remember. Okay, so you see between the first one and the second one, right? Okay, the only difference is the one is plus 2ab, the other one is minus 2ab. Okay, the a square, the plus a square and plus b square, they are the same, exactly the same. Okay, so you see this one plus 2ab, it gives you a plus b whole thing square, and this is minus 2ab. Okay, it gives you a minus b whole thing square. Okay, so this will help you to remember the first two. The last one is a square minus b square. So it is not a square plus b square. A lot of students make this error. Okay, not the same. Not the same. Okay, it's a square minus b square. It will give you a plus b, a minus b in brackets. Okay, so let's learn how to identify the first type of algebraic identity. So this guy, okay, is the a square plus 2ab plus b square equals to a plus b whole thing squared. So how do we recognize that this guy, x squared plus 2x plus 1, falls into the category of a plus b whole thing squared? Okay, so for students who are unable to see it at first sight, what I encourage them to do is always to write out a so-called standard in the format lah. Okay, so we'll do this plus 2 times of this, and you change color. Okay, so clearly please don't do this in your exam, it's going to take up too much time, but this is just in case at the start you are unable to recognize it. Okay, let's do change this to a neutral color. Okay, so what is this so-called standard template? Okay, see, okay, let's look at this guy over here. So x square, right? Okay, if x square is your so-called a square, your a will be equals to, yes, that's right, it will be equals to x. Okay, so if you put x over here, you need to put x over here as well. Okay, then if you put, okay, let's see who is the b square. Okay, if your b square equals to 1, your b will be equals to 1 as well. Good. Okay, so let's check over here. Okay, see, I have this guy in the red bracket. Okay, and this guy in the blue bracket. Okay, they should tally up to become x squared plus 2x plus 1, x squared plus 2x plus 1. Okay, so this works out, right? Okay, so condition satisfied. Okay, so in that case, we know that, okay, this falls into the category of a squared plus 2ab plus b squared. So in that case, we can use this identity of a plus b whole thing squared. So who's your A? Your A is the guy in the red bracket, which is x. Okay. Who's your B? Your B is the guy in the blue bracket, which is 1. Okay. That is why we have x squared. Okay, x plus 1 whole thing squared. Okay. We use the same example, we use the same method for the second example. Okay. 49 e squared. Sorry. Okay, now let's ignore this. 49 e squared, okay, plus 28e plus 4. Okay, so you see, I put this in this bracket. Okay, and I put this in this bracket. Okay, so we identify, okay, 7e whole thing square will give me 49e square, right? Okay, so I put it into here and here. Okay, then after that, okay, I realize that 2 square will give me 4. So I put 2 into here and here. Okay, so after I check the whole expression to see if this whole thing would give me 49e squared plus 28e plus 4. And true enough, okay, it does give me back to 49e squared plus 28e plus 4. So I will put it into this bracket of a plus b whole thing squared. Okay, third example, 25s squared. Okay, so 25s squared is actually equals to 5s whole thing squared. Right. Okay, so since that's the case, I identified what's the a. I'll put it into this bracket as well. Okay, and okay, this guy 9t squared. So 9t squared, right, equals to 3t whole thing squared. Okay, so if that's the case, I identified that 3t is the b, so I'll put it inside here as well. Okay, so this is your so-called a, and this is your so-called b. There you have this nice expression. See, that saves you a lot of time. Okay, there are some students who learn that, oh, I should use the grid method for all types of expressions. But if you know how to use special algebraic identities to solve the question, it actually does save you a lot of time. Okay, so the next identity that we need to recognize is the a squared minus 2ab plus b squared, and that will be equals to a minus b whole thing squared. So, okay, the first example that we have over here would be x squared minus 2x plus 1. Okay, so similar to the previous example, we need to be able to realize that it is x squared minus, this time around is minus, okay, something squared. So since I put the x down here, I'll put the x over here as well. And 1 squared is still 1, so I'll put a 1 here. Okay, then we should be able to, this is equals to x minus 1 whole thing squared. Notice that this minus, okay, follows the sign over here. Okay, so as per the previous example, okay, I'll put something squared minus 2 times of something. This will give me square. So let's identify what is the first square. 49e squared is actually 7e whole thing squared. Okay, since I put 7e here, let's put 7e here. Okay, and 4 is actually 2 squared, so I put it 2 squared. Okay, so let's check whether the middle term multiplies to become negative 28e. So 2 times 2 times 7e. That does give me negative 28e. So this allows me to instantly recognize that it can be factorized immediately into 7e minus 2 whole thing squared. Okay, and for the same example, whole thing squared minus 2 times of this will give me, okay, let's try out. So 25 s squared is actually equals to 5s whole thing squared. Okay, since I put 5s here, I will put 5s here as well. Okay, and let's look at the last term, which is 9t squared. That's actually equals to 3t whole thing squared. So I'll put 3t here. Let's check the middle term. 2 times 5s times 3t, that will be equals to negative 30 st. So the math checks out. That will be equals to 5s minus 3t. Okay, so this is how you are supposed to use the second special algebraic identity. Okay, so now it's time to move on to the third special algebraic identity. So before I start introducing this special identity, okay, I need to draw attention to some very special numbers over here. So these numbers, okay, why are they special? Because they are actually running sequence of squares. 1 square, 2 square, 3 square, and so on and so forth. Okay, it will be very useful for you if you can start to remember all of them. Okay, start to recognize them. Okay, so that you see, when you see, oh, see, 49 is square. Oh, you straight away recognize that, oh, this is a square of something. Square of what? 7 square. Okay, 25f square. Oh, this is 5 square. It will hasten your speed a great deal. Okay, so go and try and remember all of these numbers. Okay, usually it should be sufficient to remember up to 100, but you know, if you want to put your best foot forward and go the extra mile, why not? Okay, so let's move on to look at some of the examples of this and how to approach the questions. Okay, so the first example we have 9x squared minus 36. So let's try to identify, okay, what are the squares. So let's put the blank. Okay, let's put the blank template. So it's something square minus something square. So 9x squared is actually 3x whole thing squared, and 36 is actually 6 squared. So this is your A and this is your B, right? So if you were to put it in two brackets, okay, your A will be 3x and your B would be 6. So 3x plus 6, 3x minus 6, right? So is this the final answer? No, if you were to write this as a final answer, your teacher is going to minus off some marks because this is not the full factorization. Remember, what is the first step of factorization? It is to take out common factor. Did we do that? We didn't do that. Okay, so that's where it went wrong. Okay, because if you were to look further, right, oh, there's a 3 from here and there's a 3 from here, so you're gonna end up with 9, right? Will work. Okay, let's try to do this question by first taking out the common factor. So, okay, this one, okay, 9x squared minus 36. Okay, so I'll do here 9x squared minus 36. Right, so the first step that we wish you have done would be to take out the common factor. What is the common factor between 9x squared and 36? Okay, it is actually the number 9. If you take out 9, okay, what you're left with is x squared minus 4, because 36 divided by 9 is actually 4. Okay, after you got this, okay, you need to identify, the 9 remains outside, you need to identify who is the so-called square. So it's actually something squared minus something squared, right? Okay, so it's actually x squared minus 2 squared. So it's 9 times of, okay, let's write it. So this guy is your A and this guy is your B. So this is your A plus your B, which is 2. Okay, this is the final answer. Okay, so please learn to take out common factor. Always make it a habit to take out common factor first. Okay, so So second example, let's look at this. This is 49e squared minus 25x squared. So let's think to ourselves, is there a common factor? No, not likely. Okay, so let's proceed with our something squared minus something squared. Okay, 49e squared is actually 7e whole thing squared. Okay, 25f squared is actually 5f whole thing squared. So this is your A and this is your B. Okay. So the A is 7e and your B is, this will be 5f. Okay, this is your okay. Okay, for the last one, okay, the steps are already done over here. Okay, so notice that the first step would be to take out the common factor of 2. Then, why is this important? Because at first glance, you see 200 s squared. Hey, that doesn't belong to any of the squares over here. But if you were to divide it by 2, you realize that it becomes 2 times of 100 s squared and negative 49t squared, which 100 is a square and 49 is a square as well. Okay, and you will be able to end up with a fully factorized form at the end. Okay, so what happens when, if let's say we try to take out the common factor, okay, take out common factor as the first step, right? And there doesn't seem to be a common factor, right? Let's say for this question, x squared plus 7x plus 10. There's no common factor, right? So let's try to do the next step, which is to identify algebraic identities, right? Does it seem like there is any algebraic identity for this? No, there isn't, because you see, right, this guy is not a square. This is not b squared, right? You don't look at b squared. It's not. Okay, so when the first two steps fail to move the question along, that is when you use the grid and cross method. Okay, some schools teach grid method, some schools teach the cross method. Okay, so for my demonstration, I will show you the cross method. Okay, they both work on the same logic. Okay, so let's see, x squared, right? Okay, let's try to form this x squared first. X squared is always, it can be x squared, it can be t squared, it can be q squared, whatever. It is the quadratic term, the one with the variable square. Okay, so how do we get x squared? It is actually x multiplied by x, right? Okay, then the second term that we use is not going to be 7x, but it's going to be 10. Okay, how do we get 10? Let's try 2 multiplied by 5. Okay, so we will have, okay, let's do the cross multiply and see if we eventually end up with 7x if we multiply and add them together. So x times 2 will give me 2x. X times 5 will give me 5x. Okay, when we add them up together, it should give me 7x. And since this works, okay, this will be the factorized form, where this is x plus 2 as the first bracket, and this is x plus 5 as the second bracket. Okay, there we have it. This is how you factorize it. Okay. Okay, so now I'm going to demonstrate to you how to use the grid method. Okay, so you only need to use one of them, either grid or cross method. Okay, don't need to use both. Okay, for the same question. So for the grid method, right? So we draw a grid. Okay, so the idea of it is, okay, you want to form x squared, right? How do we form x squared? X, okay, multiplied by x. You're gonna get x squared, right? Okay, then you want to get 10 over here. How do you get 10? 2 multiplied by 5. 2 5, right? So 2 times times x will give you 2x. X times 5 will give me 5x. Okay, let's check if the two of them added up together will give me 7x. Yes, it does. So it satisfies. This one will be my first factor, x plus 2. And this one will be my second factor, x plus 5. Okay. Okay, let's do some practice using this method. So, following these steps, let's check whether there's any common factor. No, there isn't. So, common factor, don't have. Okay, is there any algebraic identities? Don't have. So, that is when we use the read and cross method. Okay, so, okay, let's try using the cross method. Okay, so how do we get 4x squared? Okay, can we do 2x and 2x? And this guy we get negative 1 and 1, because negative 1 and 1 is the only way to form negative 1, right? Okay, so this one you're going to get 4x squared, right? And this is going to get negative 1. Okay, let's try multiply each other. Oh no, we're going to get negative 2x. We're going to get 2x. We add them up to each other, we get 0. It is not equals to the middle term. So this is not the case. Okay, so let's try a different factor. So since we use 2x and 2x, that doesn't work, right? Let's try using 4x and x itself. Okay, again, okay, negative 1 times 1 is the only way that you get 1, but it matters where you put the negative 1. Okay, so either you put it here, or you put it here, or you put it here. Okay, okay, let's try putting 1 first, then we put negative 1. Okay, so for x times x, you're going to add 4x squared, which is correct. Okay, negative 1 times 1, you're going to end up with negative 1, that's correct. Let's cross multiply. X times 1, you get x. 4x times negative 1, you get negative 4x. Add them up together. Do we get the middle term of negative 3x? Yes. So, this is how you do it. Okay, if you were to switch around and this became negative, this became positive, okay, you're gonna get negative x plus positive 4x. You're gonna add with positive 3x, which is wrong. Okay, so you need to follow it. Okay, so following this example, you will end up with x minus 1 times 4x plus 1. Okay, so what happens when we try the first few methods of getting out the common factor and there doesn't seem to be any common factor? Then we identify algebraic identities and there doesn't seem to be any, and we use the grid and cross method and it doesn't seem to work. Okay, what do? Do we give up on life? No, we use the fourth method, which is to use the grouping method. Okay, so grouping method is actually a more advanced way of taking out the common factor. Okay, what do I mean? Okay, take a look at this. Okay, you need to be especially alert that it might be a grouping method question when you count and there are 4 terms in the question. Okay, so how do we proceed to do the grouping method? Let's look at the first example. Okay, so what I will do would be to group the first 2 terms together and the last 2 terms together. Okay, so grouping 4x plus 10y together, okay, I'll take out a common factor of 2. Okay, that will give me 2x plus 5y. Okay, and as for negative 15ay minus 6ax, I'll take out a common factor of negative 3a. Take note that taking out negative 3a means that negative 15ay divided by negative 3a will give me 5y. Okay, negative 6ax divided by negative 3a divide. Okay, it will give me 2x, right? This guy cancel each other, this guy cancel each other. Okay, so this is where students tend to make careless mistakes. Okay, they will happily put, oh, this equals to 5y minus 2x. They're wrong. Okay, and they say question very hard. No, it's just student make a careless mistake. Okay, so that is where we need to pay more attention. Okay, so that being said, okay, let's come back to the question. So notice that this is 2x plus 5y and this is 5y plus 2x. That's where I want to ask you a question. Is a plus b equals to b plus a? Yes. So they are exactly the same. So I will bring them to the front. What is left behind is 2 and negative 3a. So the next bracket will be 2 minus 3a. Okay, let's take a look at the second example. 12ax plus 2by minus 3ay minus 8bx. Wow, so if we were to group the first two terms and the next two terms together, oh dear, there doesn't seem to be any common factor across the second group, right? There's no common factor. What do? Okay, that's when I will ask you, is a plus b plus c plus d the same as a plus c plus b plus d? Yes. Okay, I'm just jumbling up the sequence. So similarly, I will rearrange these four terms until it gives me a favorable group. Okay, 12ax and negative 3ay. And for the second group, I will get negative 8bx and 2by. Okay, so grouping them together, for the first group, I will take out 3a, okay, end up with 4x minus y. For the second group, I will take out negative 2b. Take note that 2by, positive 2by, when divided by negative 2b, I will get negative y. Okay, so you end up with 2 exactly the same. And now take out common factor to make it front. Who's left behind is 3a and negative 2b. And this will be the second group. Okay, so now that you have these four steps, okay, you can pretty much conquer any question in factorization. Okay, remember to always follow the sequence where you firstly check whether there's any common factor to take out. Okay, failing which, see if you can identify any algebraic identities. Okay, if there isn't, then you use your pre and cross method. Okay, and last but not least, okay, if all the first three methods doesn't seem to work, then you use your grouping method. Okay, there are 4 terms usually. Okay. Okay, so as with all things, there are always exceptions, right? So similarly, okay, there are exciting ways for your examiners to test you and make life difficult for you. But don't worry, after you listen to this, it will be easy for you. So, okay, remember when I said that when there are 4 terms, okay, use grouping. Okay, if you try to use grouping here, you will see nothing but misery and sadness. Okay, so this is actually a hybrid question. Okay, so how do we approach this type of question? Okay, try to look for something that you can factorize first. Okay, so in this case, my very well trained eyes can see that this guy is actually factorizable. Under what? Okay, if I were to give this guy as a standalone question to you, you should be able to do this pretty easily because it is actually a something square plus 2 times of something something. Okay, the first guy is actually 2x, right? This guy is actually, so you end up with 2x plus 1 whole thing squared, right? Let's try to write that down. Okay, now with 2x plus 1 whole thing squared. Okay, let's try it. u minus something squared. 9y squared is actually equals to 3y, whole thing squared. Okay, this is something squared minus something squared, right? Remember, when we have something squared minus something squared, you end up with this is your a, this is your b, a plus b, a minus b, right? A minus b squared. Okay, so in this case, this guy is your a, and this guy is your b. So let's try it out. Okay. This is your a, right? 2x plus 1. This is your a. This guy is your b. So you plus 3y minus 3y. You're going to end up with 2x plus 3y plus 1. Is the first bracket. 2x plus 1 minus 3y. That's the second bracket. This is how you solve it. That was an example of a hybrid question where it is a combination of these two algebraic identities. Okay, there are other ways that the examiner can be creative, but the key idea is always stay calm. Okay, and think back to all your steps. Okay, and see if it is a combination of these 4 algebraic factorization methods, and you should be fine. If anything, you can always ask me the question.